All right, welcome to Term 2 of Statistics. So today we're going to start our new unit, and this, I'll be honest, my least favorite unit because it has nothing to do with math. It's all about samples, surveys, experiments, and it's just rather boring. Unfortunately, the days you're not here, I'm not going to get to do the warm-up with you guys because, like, at least this one, I need your input. So we're just going to jump straight into notes. And today is going to be a ton of definitions. I apologize in advance. But that's the biggest thing right now that we are going to be talking about. Like I said, there's very little math in this unit. So sampling and surveys. In a statistical study, the entire group of individuals about which we want information is called the population. If we were able to get information from every individual, then the survey would actually be called a census. More often, we must take a sample of the population, and then we use the information from the sample to draw conclusions about the entire population. We would like our sample to be representative of the population. And what that means is if the sample is a good representation of the entire population, then the results from the sample can be accurately used to represent the whole population. I'm really, okay, sorry. So you guys know I'm not the best with words, so let's see how I can paraphrase this. Results from sample accurately represent those of the whole population. And I'm going to abbreviate population because my handwriting's too big. All right, so it's kind of hard to tell, but that's supposed to be italicized. That's an example problem, something like you'll see in your homework. A high school's student newspaper plans to survey local businesses about the importance of students as customers. From telephone book listings, the newspaper staff chooses 150 businesses at random. Of these, 73 return the questionnaire mailed by the staff. Identify the population and the sample. So, to me, it's easier to identify the sample first, probably because usually it's attached to a number. So in this case, the 73 that return the questionnaire comprise our sample. And then the population would be all those local businesses. Now, don't confuse it with the fact that they chose 150 at random. If all 150 had responded, that would have been their sample. Okay, but out of that 150, they chose only 73 returns, so that's their sample. But the population is just all local businesses. So of course, when you're sampling, you can sample poorly and you can sample well. We're going to talk about poorly first. So a sample that consists of people who choose themselves by responding to an appeal is what we call a voluntary response sample. Voluntary response sample. And of course, when you have that kind of sample, you're only going to get people who have really strong opinions. And my example here is Ann Landers, which probably none of you know who she is. She used to be, actually she might still be, I don't get the newspaper anymore. She was a newspaper columnist, kind of like one of those advice people, which I know they have totally online. But so people would write into her and ask for advice. And one time this, I think it was a lady, I can't remember, wrote in and asked about if people could go back and redo, would they have kids again? And so she threw it out there to all her readers, and she said, you know, let me know if you could go back. Would you have kids again? And the responses she got were very strongly no. We would not have kids again. So she didn't have like a balance. She had no. If we could do it again, we would not have kids. And maybe a few sprinklings of, oh, I love my kids, it's the best thing ever. But for the most part, she got all responses of, no, I wouldn't have kids again. So that's my example of voluntary response. Because as somebody who has 3 kids, I would do it again. There's hard times and there's fun times, but and I also probably wouldn't have taken the time to write into her because I'm hanging out with my kids. So, sorry. A sample that consists of people who are easy to reach is called a convenience sample. So, if you needed to, say, get 100 responses on a survey, I say the mall is my example, but malls are becoming more and more obsolete. So just going to like a store and standing outside. I don't know if you guys have ever been approached. I have at like Target by people who want me to sign a petition for whatever. They're trying to get enough signatures so they can get something on the ballot. And that's a convenient sample. So both of these models for sampling may show bias. Bias consistently overestimates or underestimates the variable of interest. And it systematically favors certain outcomes. So again, at the bottom, that's supposed to be italicized writing, and it's a homework problem example, like what you'll see in your homework. So for the following situation, identify the sampling method used, then explain how the method could lead to bias. A farmer brings a juice company several crates of oranges each week. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all the oranges. So you guys will see in class, I get to have a little more interaction with you. I'd ask you guys where you think, first of all, is it a voluntary response sample or a convenience sample? This one, convenience sample, because it's convenient to look at the oranges from the top. And then how it could lead to bias. I don't know about you guys, but well, I always say that. I'm an honest person. I like to say I am. I think I am. You could ask my husband. I'm pretty honest. And so I always say, well, if I was the farmer, I'd put the good oranges at the top and the crappy ones at the bottom because, well, he only looks at the top. So it could lead to overestimating how the oranges look because of the way that the farmer puts them in there. So on top they put the good ones, on the bottom they put the bad ones. So that could lead to bias. But me personally, I don't think I'd do that. I say that, but if I was a farmer and my livelihood depended upon it, maybe I'd change my mind. All right, so that's poor sampling, voluntary response, convenience. Now we're going to talk about well, how to sample well. So good sampling techniques all utilize random sampling. A simple random sample, also known as an SRS from here on out, told myself to write small, I still didn't put it. So you'll hear me call it SRS. I'll say an SRS. Okay. So a simple random sample of n individuals from the population is chosen in such a way that every set of n individuals has an equal chance of being the sample actually chosen. A table of random digits can help us with this, and we've used that before. Also known as table D, because in the appendix of the textbook I took it from, they labeled it as table D. So a table of random digits can be used to randomly select individuals. Each entry in the table is equally likely to be any of 10 digits because we have 0 through 9. Each entry is independent of the previous one. So knowing the previous entry does not affect the following entry. So when it comes to choosing an SRS, and we talked about this before last term. Step 1 is the label. Make sure that we give each member of the population a label that is the same length. And then we have to read digits of the appropriate length from table D. And what do? If we get a repeat, we ignore it. And yes, I'm going to go over how to use it again, although I put it over here for some odd reason. There it is. Alright, so we're going to use table D. I say or your calculator. If you have a graphing calculator, I can show you how to do it on your calculator, much easier. If you don't, though, table D works great. So you want to ask a sample, Sarius Maple, of high school students. Question: how much do you trust information about health that you find on the internet? A great deal, somewhat, not much, or not at all. You try out this and other questions on a pilot group of 5 students chosen from your class. The class members are listed below by last name. Explain how you would use a line of table D to choose an SRS of 5 students from the following list. Explain your method clearly enough for a classmate to obtain your results. So, first of all, we have to know how many students are in here. So we have 1, 2, 3, 4, 5 columns. 1, 2, 3, 4, 5, 6, 7, 8. So we have 40 students. So we need to have labels that are 2 digits. So we could go 0, 0 to 39, or we could do 0, 1 to 40. I'm going to go with 0, 1 to 40. So first thing, we're going to label each name with a number. And like I said, we're going to go 0, 1 to 40. Or you could do 0, 0 to 39. And it doesn't matter if you go across or down. Let's go across. Going across. So 0, 1, 0, 2. I have to say this is probably my least favorite part, actually, is putting the numbers next to them. So that's 11, 16, 21, 20. Sorry. I don't know why I find it easier to. I should have probably just gone straight down, because I find it easier to do it this way. 32, 37. That's 13, 18, 28, 33, 38. My hand is not used to writing this much. All right, and then step 2 is to use the table and to get our 5 two-digit numbers. And we need 5 unique numbers, I should say, because we can't repeat a kid. Between 0, 1, and 40. All right, and oh, I do say it. In B, it says use line 107 to select the sample. I was like, usually it tells you the number. All right, so line 107. I'm going to use this. Ignore the see-through stuff. Line 107. So we're reading 2-digit numbers. So the first 2-digit number is 82. I'm only paying attention to numbers 0, 1 through 40. So 82, 73, 95, 78, 90, 20, I'm going to put it here, 80. Oh, and remember, like 7 to 4, I put them together, it's 74. 75, 11. 81, 67, 65, 53, 0, 0. Dang it, we should have used 0, 0. 94, 38, that's one. 31. Then I have 48, 93. I got to the end of that line, and I don't have 5 unique numbers, so I just moved down to the next line. 60, 94, 07. Oops, sorry. So 20, 11, 38, 31, and 7. Those are my people. 20 to 20, that is Velasco. I'm sure I butchered that, I'm sorry. Batista. 38, Murphy. 31, Callaway. And then 7, Ramos. I'm sorry. That's why I teach math. I'm not good with pronunciation. I actually was talking to this with my kid's pediatrician, that I feel like I can't help my daughter with reading because I'm not good at sounding things out. All right. So we found our 5. That's how we use table D. Like I said, if you have a graphing calculator, bring it in. I'll show you how to do it much simpler. So there are a couple other sampling methods, and we're going to look at those really quick. So a sample which is found by first dividing the population into groups of similar individuals, known as strata, then finding an SRS for each strata, is called a stratified random sample. This is the first time my example is going to make sense. I've been teaching statistics for 6 or 7 years. I can't remember. And every year when I get to stratified random sample, I'm like, it's homeroom. And kids are like, what? Because we've never really had homeroom. Well, we have homeroom. We took homeroom, which was we broke students up by their grades. So we put a bunch of freshmen together, and then we put a bunch of sophomores together, and juniors and seniors. Sorry, I feel like I have something in my eye. So break high school up by grade. So freshman, I'm going to abbreviate freshman, sophomore, junior, senior. Then sample from each. So that was similar individuals. When you take a sample that is found by dividing the population into groups and then selecting an SRS of the groups is called a cluster sample. And each group, here's the catcher, each group should mirror the characteristics of the population. Oops, I forgot the word sample. Trying to think of a good example for that one. I guess sticking with the high school theme, maybe I'm going to go with math. Let's say like an Algebra 2 class, because you could have freshmen in there, sophomores in there, juniors in there, and seniors. Maybe actually a better one would be PE, because I don't think PE is broken up by grade at all. So like a PE class, you have all different levels of high schoolers, so that in theory could mirror the population. So if I looked at a bunch of the PE classes and then from those PE classes took samples, that would be a cluster sample. So PE classes, or any class where you have freshmen, sophomores, juniors, and seniors mixed together. All right, and then the last one, which I always talk about, it's not going to come up, but it comes up in life. So I like to put it in there, but it doesn't actually, we don't use it in statistics, at least not this level of statistics. So a sample in which one selects successively smaller groups within the populations in stages is called a multi-stage sample. And we're not going to use it, like I said, we're not going to use it at this level of statistics, but it shows up in presidential polls. So this last fall when we had a presidential election, they would say that their polls said that this one had this much support and that one had that much support. They were taking multi-stage samples. All right, so now we're going to focus on sampling well, and these two for my next example, and this is like you'll see in your homework. And then we're done. All right, the manager of a sports arena wants to learn more about the financial status of the people who are attending an NBA game. He would like to give a survey to a representative sample of the more than 20,000 fans in attendance. Ticket prices for the game vary a great deal. Seats near the court, I need to update my numbers. We took our oldest to an NBA game pre-COVID, and the prices were ridiculous. I think it was like $100 for the nosebleeds. So they vary a great deal. Seats near the court cost over $100, while seats in the top row cost about $25. The arena is divided into 30 numbered sections from 101 to 130. Each section has a row of seats labeled with letters from A, that's closest to the court, to double Z, the top row of the arena. So first of all, explain why it might be difficult to give the survey to an SRS of 200 fans. So remember, SRS means simple random sample. So they just randomly pick 200 people from the 20,000. So there's lots of different reasons that this isn't the best way to do a sample in a sports arena. First of all, 200 people, like, do you pick the first 200 that walk in? That technically is a convenient sample. If you assign them each number 1 to 20,000, and you're using the table of random digits, that's what 20,000 is, 5 digits. So you have to have 5-digit labels, and it's not the simplest. And then once you have those 200 numbers, they could be like anywhere. So it's really, the people are spread out. I don't know about you guys, but if I was at an NBA game and they were like, hey, can you take a survey? I'd be like, no, I want to watch the game. So lots of different things. Too spread out. How labeled, that's an H, not an N. Watch game. And then I said one other. Oh, the easiest way would be convenience. And obviously that's a poor sampling method, so we want to avoid it. So which would be a better way to take a stratified random sample of fans using the lettered rows or numbered sections? So remember, stratified means you want to put them in the individuals into similar groups. So for stratified here, you would want to take the lettered rows as your strata, because the rows would group them by similar prices for what they paid for their ticket. Guy, it could be a female, is interested in financial status, we would want to group them similarly by prices of their tickets, because that, for the most part, somebody who's willing to pay, you know, in the middle is probably not super rich, but not, you know, not to the point where they're like, we want to go, but we're only going to spend $25. I hope that made sense. And then so obviously the cluster sample would be the opposite, to take the numbered sections as your clusters, because in my head I always picture this. So here's our arena, and the rows as they go up, they cost less, right? But they have their numbered section. Sorry, I wanted to make sure I used numbers instead of letters. And within this numbered section, you have people really close to the court and then people not close to the court. So that numbered section, in theory, should mirror the entire arena, because we have people willing to pay top dollar to be right on the court, and then people who want to go to the game but not, break the bank. So numbered sections make a better cluster, because clusters should mirror the population. All right, so homework and Canvas, and I will see you guys tomorrow. Yay, I get to see faces, your faces. I got to see faces today, but I get to see your faces tomorrow. And if you have questions about any of this or the homework, make sure you bring them tomorrow. We'll go over them first thing, and then we'll move into our next lesson.